Good afternoon, everyone. Did you submit assignment for guys? Or not yet? Oh, very good, very good. Don't forget, today is the deadline. Okay, guys, let's begin. So again, we will wait until 12:16. So we start with attendance and we discuss everything. So, hello, everyone. So guys, let's start with attendance. It's almost 12:17. Yes, yes, to attempt. Please click on yes for present, guys. Again, guys, please click on yes for present. So, guys, first of all, have you seen, did you see model that assignment 3, in-class assignment 2, which is 60 minutes, is next week. So here, let's write week 14 next week, and more precisely on Tuesday. So after exactly 1 day, 1 week, on Wednesday, so today is 19 plus 7, 26. You have, what do we have? ICA 2. First lecture, guys. ICA 2, 60 minutes, don't forget, only 60 minutes. And what are the material? Material is only 15.1 and, 5.1 and 5.3 only. So this one is on Tuesday, 26th of January, next week, exactly after 1 week. Okay, guys? Not Thursday. Yes, this week we'll take chapter 5. Today we will finish 5.1 and Thursday we finish 5.3. And guys, in addition to this one, you need also the material of 3.6, only natural basis. Means what's the natural basis for Rn, natural basis for Pn? We have seen this one, natural basis. Okay, guys, and please avoid being absent on Tuesday because, as you know, when you make ICA, it will be easier than makeup. Okay, guys, not makeup is not more difficult, but it will be more in details, more in details. So here, if you follow my lecture, everything will be very easy for you. You finish very easy. But for makeup will be more detailed. So also in the lecture, but more details. Look, Mariam, it's written here. What's written here? Material, everything, everything. In fact, for linear algebra, it's easy because you have, do you remember for span and linear independent, we were using REF and RREF. So basically, linear algebra is all connected. So it's all basically one idea. So it's easy. So please don't forget, for those who comes late, next week we have, so please click on yes for present again. Okay. So next week, don't forget, we have first lecture, we have on Tuesday, we have in-class assignment. No problem, Khalifa. And guys, for today, what do we have today? Today is the deadline for assignment 4. If you are late 1 second, you know what meaning of 1 second? You are late, minus 40%. Means don't keep yourself. Look, Naima, here it's written. What's written here? Here also, this one plus this one. So here and 3.6. 5.1, 5.3, and 3.6, okay? 3.6, I need only natural basis, not everything. I'm not going to ask you prove its basis or dimension. Just what's the natural basis, what's the dimension, that's it. No more details, for example, span and linearly independent. Okay, guys? Clear? Any more questions about in-class assignment? So please keep it in mind next week on Thursday. And tell all your friends, okay guys? Remind them, all of you. Like this, even they will remind you later if you forget. Okay, now let's start our lecture about chapter 5. Can you see the lecture? Okay. So, for chapter 5, today we will do 15.1 and 15.2, 15.1. So we will talk about linear transformation. So today we will talk about linear transformation, and Thursday we talk about matrices. And basically, in-class assignment will be almost from matrices. But for the moment, let's see first what's the meaning of linear transformation. Today we'll focus only about linear transformation. What's the meaning of linear transformation? And so here, definition. If we have two vector spaces, V and W, any two vector spaces, so V can be anything, for example, R2 or P3 or anything, or matrices, okay? Any vector space. We know we have many examples about vector spaces. And L is a function. So look here, guys. L from vector space to another vector space. If we have here input from V, L of U will be what? What is this? Output. Okay, this is a function. We have input and output, correct? This is a function. We give input, it gives us the output. So the input is from V, from the vector space V, and the output is from the vector space W. Clear? Clear what's the meaning of this function? Function now. We are talking about function. Okay, well, we have function from vector space to another vector space. So we take vector, just a second, guys. So Nora, here we are talking only about the function. You know what's meaning function. As before for calculus, you have like before you had only L function. You call it F maybe from R to R. Now we are calling it L. Okay, I call it L, not F. Here, if I have X as input, you have F of X. Here I call it L of X, but here not X. I call it vector U. Instead of R here I have V, instead of R here I have W, because it can be different. So here, look what we have. We have L from V to W. I have input here, vector input. You give input, it gives you the output. Here it's defined by like this one. This one, we call it linear transformation if A and B are verified. What's A? LU plus V is equal to LU plus LV. B, LCU equal to CLU. If this one is correct and this one is correct, then we have linear transformation. Let's see an example step by step. Okay, guys? Don't worry. Everything will be in detail here. We'll do it step by step. Look here. What do we have? We have L from R square cube to R cube. So for every L, we have L of U. For every U input, we have here output, correct? So look, this one is U, and this one is L of U. So here, let's erase this one, no need. So here, input, and this is the output. The same, means L of U. Okay, guys? We have input, we have output. Example, let's give me any input, guys, any vector. It must be input, look, 1, 2, 3, three components. Give me vector with 3 components, any vector with 3 components. No, give me numbers. Okay, 1, 2, 3. What's the output, guys? Yalla, guys, output. So you choose 3, 5, 7 again, and who else? 1, 3, 2, Maria. Yalla, guys. Here, what's the first component? You take the first component, you add 1. So take the first component plus 1. So it will be 1 plus 1. Second component, it's 2 multiply the second. You take second component. Third, it's the same. So you get 2, 4, 3. Very good. Now, 3, 5, 7. What's the output? First component. How to get the first component? You take the first component of the input. What's the first component of the input? It's 3 plus 1, 4. Here, the second component of the input multiplied by 2. 2 multiply 5. It's 10. And last component the same. Very good. Now, L321. 132, Mariam said. 132. So what's the output here, guys? All of you? 2, 3 multiply 2, 6. And last one, we keep it. Very good. L, negative 1, negative 1, 0. What's the output here? False. 0, yeah, minus 1 plus 1, 0. Minus 1 multiply 2, minus 2. And the last one, we keep Q3. We keep the last component 0. Okay, Batul? Very good. So Nora, you see, this is the function, input, output. If you want, you can take screenshot. Always keep it in mind, you have here input, inside. Pay attention, inside. Here inside is input. Here everything is output. Okay, guys? Just a second. So now, guys, what we have to do is to check A and B. A is LU plus V equal to LU plus LV. You see it here? We will check this one first. So let's check. Do we have LU plus V equal? Do we have it? LU plus LV? Look, guys. First of all, where is U? U always given. Look, it's here. U1, U2, U3. And it's correct, it must be from here, means 3 components. Okay, guys? V, the same, you produce the same, but instead of U, you put V. V1, V2, V3. Clear? So U, look, it's given always. And here, L of U, it's given. Hello? Can you hear me, guys? Okay, now let's check what's the meaning of left-hand side. What do we have in the left-hand side? Left-hand side is LU plus V. What's the meaning of U plus V? Add U plus V. What do we get? L of what? U1 plus V1. U2 plus V2. Very good. U3 plus V3. Now, what's the output of this one? Output. So first component, we take the first component of the input plus 1. So take the first component plus 1. So we get U1 plus V1 plus 1. This is the first component plus 1. Second component, you take the second component, you multiply it by 2. So second component here, multiplied by 2. So 2 U2 plus 2 V2. Isn't it? Last component, you keep the last. So U3 plus V3. Correct, guys? So look, this is the first component, and the output, you take the first component plus 1. Look, the first component plus 1. This is what we do. Now, let's see the right-hand side. We have LU plus LV. LU, look, from the definition, this is LU. LU is U1 plus 1, 2U2, U3, plus LV. LV is the same, but instead of U, you put V. V1 plus 1, 2V2, and V3. Clear? Okay, now add these two vectors. We get U1 plus V1 plus, if we add this one plus 2. 2U2 plus 2V2, U3 plus V3. Now, can you check these two vectors? Do we have left-hand side, which is LU plus V? Is it equal to LU plus LV? Do we have the same vectors here and here? No, why? Because here we have plus 1, here we have plus 2, not the same. So, what's the conclusion? Directly we stop. L is not a linear transformation. Because here, what's the definition? What's the output? You take first component plus 1. First component plus 1. We get 1, not 2. Definition here, what do you have? Okay, Hamad? Okay. No need to check B because A is false. Why we have to check B? No need. If one is false, it's not a linear transformation. No need to go for the second one. Okay. Please take screenshots. Do you have any question before we continue to next slide? Very good. Which part? Here? Look, L of U from definition. Look, this is L of U. Look, always you have here inside is U and here L of U. So look, this is L of U from the definition plus L of V, you substitute U by V. Here you put V, V, V. You add them, you get this vector. Compare, they are different, so it's not correct. Okay? Okay. Now, can you hear me? Okay. You took screenshot. So let's see another example. Okay. So guys, look here. Where is you? Here. This one is you. Everything inside. U1, U2 here, okay? And this one, all of it, this one, what is this? L of U, okay? Now, let's check. Is it a linear transformation? Let's check. Yes, this is the output. Very good. So, LU plus V, is it equal to LU plus LV? Let's check. First of all, let's take examples. Input. Give me input. Very good. We have to take only two components. No, Noura. How many here you have? Look here. One, two. Pay attention. So we have to take only two. For two, set for 6. And Abdullah, 5, 6. Okay, for 4, 6, what do we have? We have to take u1 squared. So take first component squared, 4 to the power of 2. Second component, it's 2 multiply 6. So we get 16 and 12. For the second one, we get 25 and 12. Okay, guys, very easy. Just substitution. Now, let's erase. Let's check LU plus V. Left-hand side. What do we have in the left-hand side? LU plus V. And let's write U, already we have it. U1, U2. V, V1, V2. So LU plus V, add U plus V, we get LU1 plus V1, U2 plus V2. Yalla guys, here this is the first component, here is the second component. What is the output? We take first component squared. So first component all squared, correct? Now, the second component, we have to take the second component multiplied by 2. So 2 multiply second component, U2 plus V2. Now we open the bracket. We get U1 squared, V1 squared, 2 U1, V1. And here 2U2 plus 2V2. Okay. Now LU plus LV. Where is LU? Look, we have it. Always LU from definition, okay guys? U1 squared, 2U2. Plus LV, so the same. Instead of U, put V. V1 squared, 2V2. So if we add them, we get U1 squared plus V1 squared, 2U2 plus 2V2. Do we have the same? Why? Because what's the difference? Here we have plus 2U1 V1. So L, directly we stop, is not a linear transformation. Please guys, is it clear 100%? Very good. أسيل محمود، فاطمة حملي، فاطمة شمالي، شيخة الفراح، شيخة طلال منصور الفراح، فاطمة الشمالي، فاطمة الحملي, Asil Mahmoud. If you don't answer, I'll put you absent. So guys, please click on yes. I will consider this one as present for those who are now here. Click on the polling. Guys, click in front of you on yes for present. If you don't click, means you are not hearing me. I will not consider you as present. تركي العجمي, طيبة السكر, شاكر عنازي, شيخة الفراح, سارة الزعبي, روان النامي. طيب ريبيت. تركي العجمي, شاكر العنازي. اوكي. تركي العجمي, شيخة الفراح, روان النامي, محمد العنازي. عبد الله حسين, انوار الغريب, أسيل محمود, طيب ديهني, خليل محمد, مريم البلوشي, روان نامي, تركي العجمي. You don't answer means absent automatically. No, I said it before, but now you click on the polling. Don't forget, next week, all of you guys, we have ICA in the first lecture. 5.1, 5.3, and what's the meaning of natural basis in 3.6. Turki Al-Ajmi, absent. Rawan Nami, absent. Mariam Blushi, absent. Khalil Muhammad, absent. Faye Dayhani, also absent. Asil Mahmoud, absent. Anwar Gharib, absent. Abdullah Hassan, absent. It means you click on the polling, don't worry. So, and guys, don't forget today, before midnight, you have to submit assessment form. If you don't submit it today, even if you are late 1 second, we don't accept. خلاص, minus 40% without sending me any email. There is no excuse. Because don't wait until the last moment. You have to submit it before the deadline. Not to wait until the deadline and you have problem. If you have internet problem, it's your problem, not my problem. There is no excuse. 1 second, it's minus 40%. Anwar Gharib, Asil Mahmoud, Khalil Muhammad, Mariam Blushi, Rawan Nami didn't click only. Others, please don't discuss if I didn't say your name. So, let's see another example. Abdullah Hassan, I said your name many times, you didn't answer. I will consider you as absent. You clicked at the last moment. Why you didn't answer before? Directly error? Okay. Next time you have to answer immediately. So guys, here we have an example also. So where is U? This one here inside is U. This is the input. And output is the result here. This is the output. L of U. Okay, guys, always you have to make it like this. So is it a linear transformation? What do you think? It will be linear transformation? No, because we have plus one again, plus one, so we will have plus two at the end. Remember? So LU plus V. First, what's the form of U? Is it U1, U2, 3, or 1, 2 only? 2 or 3? 2. U1, U2. It's here in front of us. V, it's V1, V2. So LU plus V, it will be L, U1 plus V1, U2 plus V2. So when we add, what's the answer? So it will be first component plus 1. So first component, U1 plus V1 plus 1. Second component is the same. Third component is the first plus second. So first plus second, U2 plus V2. Now we open the bracket and we put U together. Here we have only one U, so U and V, and then the rest. Here U first and V. Here I will get U1 plus U2 plus V1 plus V2. Now LU plus LV. So it's equal to U1 plus 1. Sorry, plus 1 by mistake. So U1 plus 1, U2, L of U, look, it's here, okay? This one is LU2. And LU, LU1 plus U2. Now, L of V, it's the same. Instead of U, put V. V1 plus 1, V2, V1 plus V2. So, okay, guys? So, if we add them, what do we get? U1 plus V1 plus 2, U2 plus V2, U1 plus U2 plus V1 plus V2. So, do we have LU plus V? This one, Nura, nothing. Look here. This one's the same. This one's the same. Here, open the bracket. U1 plus V1 plus U2 plus V2. Put U together. U1 plus U2, V1 plus V2. Nothing. I didn't do anything. Okay? So LU plus V, is it equal to LU plus LV? No. So L is not a linear transformation. So again here, it comes from here. It's different. LU plus V, different LU plus LV. Please, any question, feel free and ask me. Nora, is it understood for the last step? Yes, Abdullah, which step? Here? This one here? Yes, LU plus V is this one. Definition, this one is fine, right? This one, you know how to get it? Okay. And here, open the bracket. U1 plus V1 plus U2 plus V2, right? So here, like you have 3 plus 4, I put 4 plus 3, the same. I put U2 plus V1. I interchange, just put U together and V together. That's it. Any question, guys? Okay, very good. Please take screenshot if everything is fine. This one. Exercise 1 from the textbook. We have L from R2 to R3, U, this is U, and L of U. Is L a linear transformation? So let's check LU plus V. First, we have to take U. What's the form of U? 2 or 3? 2. So U1, U2. And V is V1, V2. So LU plus V. Please follow me, all of you. L, U1 plus V1, U2 plus V2. Is it clear for the moment? Now, definition. What's the output? We take first component plus second. So first plus second. So U1 plus V1, this is the first, plus second. U2 plus V2. Correct? Now, second component is similar to the second component of the input, which is U2 plus V2. Last component, it is the first minus second. So the first minus second. Now, open the brackets. U1 plus V1 plus U2 plus V2. U2 plus V2. U1 plus V1 minus U2 minus V2. Now we put U together and V together. Is it clear for the moment? Up to here, everything is clear? All of you? Okay. Okay. Now put U together. So here, put U2 plus V1. So we get U1 plus U2 plus V1 plus V2. Correct? I didn't do anything. Now U2 plus V2. And here, put U together. So put this one before this one. So we get U1. Here I have minus U2. How many V1? I have plus V1. And how many V2 minus V2? Correct? Is it correct or not? Very good. Now, from the right-hand side, I need LU plus LV. LU, always from the definition, you have it. Here, this is LU. So U1 plus U2. U2, U1 minus U2. L of V, the same. Instead of U, we put V. V1 plus V2. V2, V1 minus V2. So add these two vectors, what do we get? We get U1 plus U2 plus V1 plus V2. So you see, already we have U together and V together. Here, U2 plus V2. And the last one, U1 minus U2 plus V1 minus V2. Compare, do we have the same? So LU plus V, it's equal to LU plus LV. So now we have to continue. This is the first one. Clear, guys? Is it linear transformation? We don't know. We have to check part B. What do we have in part B? We need to check if LCU is equal to CLU. Let's check LCU. So L, C multiply U. U is U1, U2. So it's equal to L CO1, CO2. So it's equal to, what's the definition? Here we have input. Output is first component plus second. So first plus second, CO1 plus CO2. C is any number, okay? We don't fix number, any number. CO1 plus CO2, Nura. And second component, it's similar to the second, so CO2. And last, it's first minus second, so CO1 minus CO2. Done. Now, CLU, this is the easiest one in this part. So L of U is given U1 plus U2, U2, U1 minus U2. So we get multiply by C. CU1 plus CU2, CU2, CU1 minus CU2. Do we have the same, guys? Yes. So LCU, it's equal to CLU. Look, we have one is done, two is done. So conclusion, L is a linear transformation. Here, LCU equal LC multiply U. Clear? Multiply C multiply U1, C multiply U2, so we get CU1, CU2. Output is this one. Clear for the moment here? Here, output, you get it from here. What's the output? Yeah, multiply by C, yes. Now, CLU, it's C multiplies the output, multiply by C everything, so you get this output. Okay, Batul? Now, is it better or what? Okay. So please take screenshot and let's continue. For polynomials, guys, look here. Assume we have linear transformation L from P2 to P1 such that L P of t equal to P prime of t. So look, this is the input. And what's the output is the derivative. Okay? So tell me, what's the, so here P2 means polynomial with degree 2. Let's see, for example, 3t squared minus t plus 5. L of 2. L 3t minus t squared plus 1, let's say. Yalla guys, how to find the output? What should we do? Look, follow here. What's the output? It's the derivative. Very good, Hamad. So we do derivative here. Output is to simply derivative. Not only 16 ora. Derivative of 3t squared minus t plus 5. So what's the derivative? It's equal to 60 minus 1. Just a second, guys. And for the last one, guys, very good. So it will be derivative 3t minus t squared plus 1. So it will be 3 minus 2t. Very good. Minus 3. No, Abdullah. Here, derivative 3 minus 2t. Okay. Please take screenshot because I will change. So now look what I will do. So to R, what does mean R? Means number. So here I will put bit of 2, let's say. So instead of t, we will put, look, what's the difference? Output, you have polynomial. Instead of t here, we will put 2. So here, what's the output? Instead of t, we will put 2, right? If this one is p of t, what's the meaning of p of 2? Means the value of t equal 2. So we will get 3 times 2 squared minus 2 plus 5. So what do we get? 3 times 4, 12 minus 2, 10 plus 5, 15. N of 2. So substitute t by 2, so we get the same, 2. Here, substitute t by 2, so 3 multiply 2 minus 2 squared plus 1. So we will get 6 minus 4, 2 plus 1, 3. You see, very easy, guys. L2 equal t? No, here we don't have t. So if I want like function, constant function, so for any t is equal to t. In particular, if t equal 2, so here we don't have t, so it will stay 2. Hamad, which one? Here, look, instead of t, you will put 2. P of t. Like if you have function f of x equal 5, x, what's the meaning of f of 2? Means instead of x, put 2. Substitute x by 2, you get 10, right? So here, the same, look, you have p of t, I get p of 2. Means instead of t, put 2. Here, instead of t, put 2, you get the answer. Okay, Hamad? Okay. Please take screenshot, and let's continue. I think this is the last exercise for the moment, for this for today, because I want you only to know what's the meaning of linear transformation, how to see it's a linear transformation, and how to find output. Okay, guys? Because I don't want to start transform matrix, standard matrix. We will keep it for Thursday like this. You will digest the meaning of linear transformation. I don't want to give you everything today. Okay? Sounds good? Okay. Now let's see this one. Here, input is 3 components. Output is 3 components. Let's check. For example, give me any input, guys. 5, 7, 8. So what will be the output? So first component plus 4 multiply second. So first it's 5 plus 4 multiply 7. So 28 plus 5, it's 33. Second component, it's minus the third component. So second here, it's minus 8. Last one is second plus third. So second plus third, 7 plus 8, 15. And L, let's take 1, 2, 3, or first 3, 6, 7. Yeah, guys, give me directly the answer. So it will be 3 plus 4 multiply 6, so 27. minus 7, and 6 plus 7, 13. And last one, L1, 2, 3. It will be, so 1 plus 4 multiplied 2, so 1 plus 8, 9, minus 3, very good, and 2 plus 3, 5, very good. So you see, we have input, we compute the output, very good. So let's erase. Now let's check LU plus V. What's the form of U? 2 components or 3? U3, very good. V, it's equal to V1, V2, V3. Let's check LU plus V. LU plus V, so it will be LU1 plus V1, U2 plus V2, U3 plus V3. What's the output? So we take first component, here it's U1 plus V1, plus 4 multiply second component. Second, it's U2 plus V2. Second component is equal to minus the third component. Last is second plus third. So second plus third. Correct? Now we open the bracket, and then the last step we put U together and V together. First, open the bracket, U1 plus V1 plus 4U2 plus 4V2 minus U3 minus V3 and U2 plus V2 plus U3 plus V3. So put U together, U1, how many U2 plus 4U2? Now V plus V1 plus 4V1, correct? Okay guys, let's do it step by step all together. Please confirm everything is fine, okay? V2, very good. Now, here the same. Last one, U2, do we have U3? Yes, plus U3, plus V2, plus V3. Now let's check LU plus LV. LU, from the definition we have it. What's the first one? What do you mean what's the first one? U1 plus 4, U2. Yeah. Plus 4U2. So N of U is this one, U1 plus 4U2 minus U2 minus U3, U2 plus U3. N of V is the same, we take the same, but instead of U you put V, plus 4V2 minus V3 minus V2, V2 plus V3. Add together, what do we get? We get U1 plus 4U2 plus V1 plus 4V2. Here, minus U3 minus V3, U2 plus U3 plus V2 plus V3. So, LU plus V, very good. It's equal to LU plus L plus LV. We have the same. Now, let's see LCU. Number 2, LC multiply U1, U2, U3. Multiply C by this vector, so we will get C will multiply each component. So CU1, CU2, CU3, correct? Now, what's the output of this one? Look, first plus 4 multiply second. So first, CU1 plus 4 multiply second. Second component is minus the last component, so minus CU3. And last component, what do we have in the last one? Second plus third. So second plus third. Very good. Now, if we take CL of U, so it will be C multiply L of U, we have it from definition, U1 plus 4U2 minus U3, U2 plus U3. Here, multiply C everything, so it will be CU1 plus 4CU2 minus CU3, CU2 plus CU3. The same, very good. LCU equal to CL of U. So 1 is correct, second is correct, L is a linear transformation. Very good. Is it clear 100%, guys, all of you? Very good. So as I said, we will stop here because I don't want to start standard matrix. I want you to digest first idea, second idea, so on, all. So please revise it very well so we can continue on Thursday. Thursday is very important for ICA, guys. Please avoid being late, absent, okay? Even don't be late. Be present on time. Yes, Abdullah. Now it's time for your question. If you don't have any question, you can leave, no problem. We are done. Okay, please don't write. I want to see the question of your friends. If you don't have any question, just leave, okay? No. It will be the same questions. Thank you. Don't forget to submit assignment 4 by today. 1 minute or 1 second late is late without any discussion.